So after discussing all about the mole concept, let's talk how to find out the number of moles. Let's see how to find out the number of moles. Now, number of moles is given weight divided by molar mass. Now we will use this formula when the weight of the substance is given. For example, 100 gram of water is given to you. So 100 will be the given weight and 18 is the molar mass of water. So if you divide 100 by 18, you will get the number of moles. In the second case, number of particles are given to you. Number of particles can be atoms, molecules or ions. If you divide those number of particles by Avogadro number, that is 6.023 into 10 to the 23, you will get the number of moles. Case number 3. If the volume of the gas at NTP, now again I am saying this formula is only for gas. Please don't do this mistake. Don't apply the formula for solid or liquid. It's only and only for the gases. So, the volume of the gas at NTP is given, suppose 10 liter of oxygen at NTP. If you divide it by 22.4 liter, you will get the number of moles. So that's how we find the number of moles. So I am giving you one reference example. If you get stuck in any question in which one compound is given, you just refer the solution of this example, your problem will be solved, right? Now, in a sample of 22 gram of CO2, find the first is number of moles of CO2. 22 gram is the given weight and the weight is given, we will apply the formula given weight divided by the molar mass. So, it will be equal to the given weight upon molar mass, that is 22 divided by 44, and that will be equal to 0.5 mole. It means that in 22 grams of CO2, the number of moles will be equal to 0.5, and whenever number of moles of a molecule is asked, that will be always equal to the number of gram molecules so number of moles of CO2. CO2 is a molecule. Number of moles of CO2 will be equal to the number of gram molecules of CO2, right? Number of molecules of CO2. Now we know that in 1 mole there are 6.023 into 10 to the power 23 particles are present or molecules are present. So, it will be equal to 0.5 multiplied by 6.023 into. So these many molecules will be present in the 22 gram of CO2 and we can write it as it is equal to 0.5 into Na, right? Let's see the next part. In the next part he is asking the number of moles of carbon atom. Now, the formula of carbon dioxide is CO2. In one molecule, there will be one carbon atom and two oxygen atoms. It means that the number of molecules will be equal to the number of carbon atoms. Suppose we have 100 carbon dioxide molecules In those 100 carbon dioxide molecules, 100 carbon atoms will be present and 200 oxygen atoms will be present. So, we have 0.5 mole of CO2. Therefore, the number of carbon atoms will be equal to 0.5 because the number of carbon atoms will be equal to the number of carbon dioxide molecules, as in each molecule of carbon dioxide only one carbon atom is present. Therefore, they will be same always. Now we have to find out number of carbon atoms. We have the number of moles of carbon atoms. Again, we will apply the same formula. In 1 mole, we have 6.023 into 10 to the 23 particles. But in this case, we have 0.5 moles of carbon atom. Therefore, the total number of carbon atoms will be equal to 0.5 into Na, right? Now, the next part. Next part is number of moles of oxygen atom. Oxygen is a double of carbon. We are solving for carbon dioxide, and in CO2, one carbon is present and two oxygen atoms are present. So whenever there will be one carbon atom, there will be two oxygen atoms. If we have 100 carbon atom, there will be 200 oxygen atoms. If we have 1 mole of carbon atom, there will be 2 moles of oxygen atom. But now, in this case, we have 0.5 moles of carbon atom. Therefore, the number of moles of oxygen atom will be double of that, and that will be equal to 0.5 into 2, and that is equal to 1. And one more thing I want to tell you, whenever he asks the number of moles of any atom, that is equal to gram atoms. So, from here we can say that if we are talking about a molecule, then number of moles is the number of gram molecules. If we are talking about an atom, the number of moles are equal to number of gram atoms. So, number of oxygen atom. So, how many moles of oxygen we have? Number of moles of oxygen we have is equal to 1. Therefore, number of oxygen atoms we will have, that will be equal to Na. That is Avogadro number. Now he is asking total number of atoms. We are talking about carbon dioxide. Carbon dioxide contains carbon also and oxygen also. In this particular question, we have carbon, oxygen. The number of carbon atoms is equal to 0.5 into Na, that we have already found, and of oxygen we have Na. So you do one thing, you add these two, so carbon and oxygen, you will get the total number, and the total number is 1.5 into Na. This is the total number of atoms present in 22 grams of carbon dioxide. So what we did, we found the number of moles of CO2, we found the number of moles of carbon, we found the number of moles of oxygen, as well as we found the number of atoms of carbon and oxygen. What else? In the next question, he is asking, find the number of electrons present in the sample. Now, we have carbon and 2 oxygen atoms, and we know that the number of electrons in oxygen is 8. This is equal to 6 and again 8. So, what is the total number of electrons present in one molecule of CO2? That will be equal to 8 plus 6 plus 8, and that is equal to 22, right? Now, in 1 mole of CO2. Now here we are discussing about one molecule, and what is it? This is a molecule. Now 1 mole. So the number of electron, number of that will be equal to 22 into the Avogadro number. But in this question, we have 22 gram of CO2. We don't have 44 gram. We don't have 1 mole. We have 0.5 mole. Therefore, we can write here 1 mole of CO2, that is 44 grams. Now, in 22 grams of CO2, the number of electrons, number of electrons it will be equal to 11 into Na. So that's how we can find out the electrons present in the particular sample, and in this manner we can find out the number of neutrons also and the number of protons also, right? Now in the next case, he is asking the volume of the sample at NTP. Now we know that volume of 1 mole that is equal to 22.4 liter. And how many moles we have in this question of CO2? That is 0.5 moles. So for 0.5 moles, right? So volume of 1 mole is 22.4 liters and volume of 0.5 moles is 11.2 liters. So I hope you understood everything. Now let's solve some questions.